Metamorphosis, the process of transformation that many animals undergo during their life cycle, comes in two primary forms: complete and incomplete metamorphosis. Each of these processes has its pros and cons, which have shaped the evolution of different species in unique ways over millions of years. Complete metamorphosis is like watching a magic trick. An insect begins life as an egg, hatches into a larva, transforms into a pupa, and then emerges as a completely different creature, an adult butterfly, for example. This dramatic transformation, where the larval stage often looks nothing like the adult, first evolved during the Mesozoic Era. Scientists believe it likely developed between the Triassic and Jurassic Periods, about 252 to 145 million years ago. A classic example is the monarch butterfly, which starts as a crawling caterpillar munching on leaves and ends up as a delicate butterfly sipping nectar from flowers. Complete metamorphosis offers the following advantages that have helped certain species thrive. First, reduced competition. The different life stages occupy different niches. For example, caterpillars eat leaves while adult butterflies feed on nectar. This reduces competition between the young and adult stages, allowing both to thrive without vying for the same resources. Second, specialization. Each stage can be highly specialized for its environment. The larva is often a feeding machine, rapidly growing and storing energy, while the adult is typically focused on reproduction and dispersal. Third, protection during transformation. The pupal stage often provides protection during the most vulnerable time. For instance, the cocoon or chrysalis shields the insect as it undergoes the complex reorganization of its body. However, complete metamorphosis also comes with some challenges. First, energy intensive. The process of completely reorganizing the body is energy intensive. The larva needs to consume a significant amount of food to prepare for the pupal stage. Second, vulnerability in pupal stage. Despite the protective casing, the pupal stage is a period of vulnerability since the insect is largely immobile and unable to defend itself or flee from predators. In contrast, incomplete metamorphosis involves a more gradual transformation. This simpler form of development first appeared much earlier, during the Paleozoic era, specifically in the Carboniferous period. Animals like grasshoppers, crickets, and dragonflies hatch from eggs as nymphs, which looks like smaller versions of the adult, but without fully developed wings or reproductive organs. Over time, the nymph molts several times, gradually acquiring adult features. Incomplete metamorphosis also has its own set of advantages. First, continuous activity. Unlike with complete metamorphosis, the nymphs are active and mobile throughout their development. They can continue to eat, grow, and avoid predators without the need for a dormant pupal stage. Second, simpler development. The development process is less complex and less energy intensive compared with complete metamorphosis. The animal gradually adds new features rather than undergoing a total transformation. Nevertheless, incomplete metamorphosis presents some challenges as well. First, increased competition. Nymphs and adults often share the same habitat and compete for the same food sources, which can lead to increased competition within the species. Second, less specialization. Because the nymph is a smaller version of the adult, there is less opportunity for specialized adaptation at different life stages. This can limit the species' ability to exploit diverse ecological niches. This raises the question, why do some animals stay incomplete while others opt for complete metamorphosis? The choice between complete and incomplete metamorphosis is largely driven by environmental factors and evolutionary pressures. For instance, insects like grasshoppers, which undergo incomplete metamorphosis, are often found in stable environments where food sources remain relatively constant. In such settings, the advantages of continuous activity and simpler development established since the Carboniferous period outweigh the benefits of a complete transformation. Grasshoppers can steadily grow and reproduce without needing to pause for a dramatic overhaul of their bodies. On the other hand, environments that are more variable or have distinct seasonal changes might favor complete metamorphosis, a process that evolved later during the Mesozoic Era. A caterpillar might thrive in the spring when leaves are abundant, but as the season changes, it can transform into a butterfly which feeds on flowers that bloom later in the year. This ability to switch roles as the environment changes provides a significant survival advantage. Both complete and incomplete metamorphosis offer unique advantages and challenges. The paths that different species have taken reflect a balance between the energy required for transformation, the need to avoid competition, and the ability to exploit different ecological niches. The diversity of life on Earth is partly due to these different strategies, each one a masterpiece of evolutionary adaptation shaped over hundreds of millions of years. Thanks for watching.